The space race was more than just a scientific endeavor. It was a monumental chapter in human history that showcased the relentless pursuit of knowledge and the unyielding spirit of exploration. It was a fierce competition between two superpowers, the United States and the Soviet Union. This rivalry was not just about reaching the stars, it was about proving which nation could achieve the impossible first. This rivalry played out on a global stage, fueled by Cold War tensions. The world watched as these two giants vied for supremacy, each success and failure broadcasted to an audience hungry for progress and innovation. Both nations sought to prove their technological superiority and, by extension, the dominance of their ideologies. The stakes were incredibly high, as each breakthrough in space technology was seen as a testament to the effectiveness of their political and economic systems. The space race captivated the world's imagination, pushing the boundaries of human ingenuity and forever altering our understanding of our place in the cosmos. It inspired generations of scientists, engineers, and dreamers to look beyond our planet and consider the infinite possibilities of space exploration. The space race was about national pride. It was a demonstration of what a nation could achieve when it set its sights on the stars and committed its resources to the pursuit of excellence. It was also about demonstrating military and technological prowess. The advancements made in space technology had far-reaching implications, influencing everything from military strategy to everyday consumer products. Each successful launch, each new milestone achieved, was a strategic victory in the broader context of the Cold War. These achievements were not just about exploring space. They were about securing a place in history and asserting dominance on the world stage. On October 4, 1957, the Soviet Union launched Sputnik 1, the world's first artificial satellite. This small metallic sphere, no larger than a beach ball, sent shockwaves across the globe. Sputnik's beeping signal, transmitted back to Earth, marked a pivotal moment in human history.
For the United States, Sputnik's launch was a wake-up call. It exposed a perceived missile gap and ignited a sense of urgency to match and surpass Soviet achievements in space. The space race, in essence, had begun.
The Soviet Union continued its string of successes with Yuri Gagarin's historic flight on April 12, 1961. Gagarin, a young Soviet cosmonaut, became the first human to journey into space. He orbited the Earth aboard the Vostok 1 spacecraft, completing a single orbit before returning safely to Earth.
Gagarin's accomplishment solidified the Soviet Union's early lead in the space race. The image of his smiling face, broadcast around the world, further fueled America's determination to catch up.
In response to Soviet achievements, President John F. Kennedy issued a bold challenge to the nation.
In a memorable speech before Congress on May 25, 1961, Kennedy declared that the United States should commit itself to landing a man on the moon and returning him safely to the Earth before the end of the decade.
This ambitious goal provided a clear focus for the American space program. It galvanized public support and spurred unprecedented levels of funding and innovation. The race to the moon had begun. Section 5. America's response. Project Mercury and Gemini. These two programs were pivotal in establishing the United States as a formidable force in space exploration during the Cold War era. To achieve Kennedy's ambitious goal of landing a man on the moon and returning him safely to Earth, NASA embarked on two critical programs, Project Mercury and Project Gemini. These programs were designed to develop the necessary technology and expertise for human spaceflight.
Project Mercury, initiated in 1958, aimed to put an American astronaut into orbit around the Earth. It was the first human spaceflight program of the United States, and it laid the groundwork for all subsequent manned space missions. The program's objectives included orbiting a manned spacecraft around Earth, investigating man's ability to function in space, and recovering both man and spacecraft safely.
Project Gemini, which followed Mercury, focused on developing the skills and technology needed for a lunar mission. This program was essential for testing the procedures and equipment that would be used in the Apollo missions. Gemini missions included long-duration flights, spacewalks, and orbital maneuvers such as rendezvous and docking.
These programs achieved significant milestones. They not only demonstrated America's technological prowess, but also showcased the bravery and resilience of the astronauts who participated in these missions.
Alan Shepard became the first American in space in 1961 aboard the Freedom 7 spacecraft. His suborbital flight lasted just over 15 minutes but marked a significant achievement in the space race. And John Glenn became the first American to orbit the Earth in 1962 aboard the Friendship 7 spacecraft. His successful mission proved that humans could survive and work in the weightlessness of space. Project Gemini saw the first American spacewalk performed by astronaut Ed White during the Gemini 4 mission in 1965. This extravehicular activity was a critical step in understanding how astronauts could work outside their spacecraft. And the first rendezvous of two spacecraft in orbit achieved during the Gemini 6 and Gemini 7 missions. This capability was crucial for the success of future lunar missions, where docking maneuvers would be necessary.
These missions provided crucial experience and paved the way for the Apollo program. The knowledge and skills gained from Project Mercury and Gemini were instrumental in achieving the goal of landing a man on the moon, fulfilling Kennedy's vision and solidifying America's leadership in space exploration.
Section 6. The Soviets' Lunar Ambitions, the Luna Program. While the United States focused on reaching the moon with their Apollo missions, the Soviet Union had its own ambitious plans for lunar exploration. Both superpowers were locked in a fierce competition, each striving to outdo the other in space achievements.
The Soviet lunar program, initiated in 1959, aimed to explore the moon with robotic probes. These missions were designed to gather crucial data about the lunar surface and environment, paving the way for potential future manned missions.
The lunar program achieved a number of notable firsts, including the first spacecraft to reach the moon's surface, Luna 2 in 1959, and the first images of the far side of the moon, Luna 3 in 1959. These groundbreaking achievements showcased the Soviet Union's technological prowess and determination to lead in space exploration.
The lunar program demonstrated the Soviet Union's continued capabilities in space. The successful launches and operations of the lunar spacecraft were a testament to the skill and dedication of Soviet scientists and engineers, who worked tirelessly to push the boundaries of space exploration.
However, despite their early successes, the Soviets faced setbacks and ultimately lost the race to land humans on the moon. Technical challenges, funding issues, and internal political struggles hindered their progress. While the lunar program made significant contributions to our understanding of the moon, it was the United States that ultimately achieved the historic milestone of landing astronauts on the lunar surface with the Apollo missions.
Section 7. One Giant Leap. Apollo 11 and the Moon Landing. On July 20, 1969, the world watched in awe as American astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon. This monumental achievement, witnessed by millions around the globe, marked a defining moment in human history. The Apollo 11 mission was the culmination of years of intense effort, technological innovation, and unwavering determination. It represented a triumph not just for the United States, but for all humankind.
Section 8. Beyond the finish line, the enduring legacy. The space race, while sparked by rivalry, ultimately transcended its Cold War origins. It left an enduring legacy that continues to shape our world today. It inspired generations of scientists, engineers, and dreamers. It pushed the boundaries of human knowledge and capability. The space race demonstrated the power of human ingenuity and the importance of international collaboration in the face of shared challenges.
Section 9. Technological Innovation, a Universe of Possibilities. The space race was a catalyst for unprecedented technological innovation. The drive to explore space led to the development of countless new technologies that have had a profound impact on our lives. From satellites that enable global communication and navigation to advancements in materials science, computing, and medical imaging, the legacy of the space race is all around us. The miniaturization of electronics, the development of new materials, and the advancements in rocketry are just a few examples of the technological leaps that were made during this era. These innovations continue to drive progress in various fields today. Section 10. A new era of exploration. International collaboration. While the space race began as a competition, it ultimately laid the foundation for international cooperation in space exploration. The International Space Station, a marvel of engineering and a symbol of global unity, stands as a testament to the power of collaboration in space. Today, nations around the world are working together to explore the cosmos, pushing the boundaries of human knowledge and seeking answers to some of the universe's greatest mysteries. The spirit of exploration, ignited during the space race, continues to burn bright.